Okay, so we're partway through the mapping, and what we've done so far are the big three, right? We've talked about just how NIEM stuff works, how you've got elements and those elements are of types. We've learned about substitution groups, and we've also learned about inheritance. If you understand those three things, you're in really good shape for the materials that follow. If you don't understand them yet, I'd highly recommend going back and re-watching those materials because you need to have those down. Those three are the bedrock everything else is built upon. If you don't understand those three concepts, you're going to have trouble with the later concepts. But if you understand them, you are good to go for continuing on. Now we're going to move into referencing. Okay, so now that we have a good idea about the three big topics and we understand them well and we have a good base to move on, now we can start to talk about some more advanced techniques and technologies that NIEM uses. And one is the ability to link things together. So in a lot of ways, NIEM is relational in that instead of being a huge hierarchy, you have separate peer level objects that get linked together in different ways, and NIEM has some ways to do that. It's very different from how a lot of people view XML. A lot of people just view XML as a huge hierarchy, everything's in the hierarchy, and while it's true that you will have an overall hierarchy, it is also true that in NIEM and in XML schema, this is actually using normal XML schema stuff, that NIEM provides a kind of relationship mapping and linking that allows it to better represent real-world objects and the many-to-many relationships real-world objects have. This all happens due to the structures namespace. Now, I've been promising for a little while now that we talk about infrastructure attributes that get added to things. That's what we're about to talk about. But before we get into the details, let's just talk a little bit about how NIEM is put together. And there's basically some structural layers to it, conceptual layers that build on top of each other. So this isn't all going to fit, so I'm going to go ahead and just get the diagram up. So what you see in this diagram is a number of boxes that are grouping together different kinds of namespaces in NIEM. And remember, the namespaces represent core and domains, but some other things as well. What you see in the bottom left here, this is a support box. These are the namespaces that provide support to everything else. One of them is called AppInfo, which is generally for things that are going to help tools work against NIEM stuff. Sometimes they're used, sometimes no tool was written to use them, but they're there anyway. Structures is what we want to focus on now, and structures provides infrastructure support to allow referencing to happen, provides some basic container types for elements to build off of. So when you looked at person type, you saw it was based on object type. Object type is here in structures and provides an empty container. Empty container with the infrastructure attributes that are going to let us do referencing in just a sec. Now everything else works off of that layer. So this layer here is the NIEM core layer, and it's got the NIEM core namespace inside. And everything in NIEM core builds off these things in structures. So NIEM core, got the gray arrow, everything in NIEM core is building off of structures, using those empty containers to build more complicated things. Off to the right, we have external standards and code lists. We haven't talked about them too much, but they also draw from the structures namespace. So everything in there gets built off of structures as well. And then at the top, you have the NIEM domains. And the NIEM domains build off of everything else. So the domains use structures. They use that infrastructure stuff. They use the data types. They use stuff from structures. Domains also, they'll use things from NIEM core. So they will build on NIEM core. We've already seen this, where we saw NIEM core had an incident type and justice had a driving incident type that derived from it. So something in justice built on something in NIEM core. The domains can also utilize code lists. So when we talk about code lists, we're going to see those, and domains draw upon those as well. And then finally, domains can draw upon each other. So human services, for example, draws things from justice because there are things in justice that apply to human services. So it will take some things from justice and make special versions of them. That doesn't happen as often as the other arrows, but it still happens. So there's a lot of borrowing from each other, but it's important to notice all these arrows all kind of point in the same direction. They all point towards the base layers. You got structures there at the bottom and everything uses it. You got NIEM core Structures doesn't use NIEM core. NIEM core uses structures. And then the domains, well, the domains use everything. But none of the things below them use the domains. NIEM core doesn't reference anything in any of the domains. And structures doesn't reference anything anywhere in any of these other namespaces. So that's the basic layered structure. The bottom line is, at the bottom, structures providing support for everything else. So how do we do this referencing? Well, it's done by applying IDs to objects and then providing references to those IDs. So NIEM lets you assign unique IDs to objects in a document. And then other elements can link to those IDs by referencing them, referencing the ID that an object has. So object 1 gets an ID. Object 2 has a reference to the ID that object 1 has. And then that links object 2 to object 1. In NIEM, we have 3 different attributes we use for this. One is the ID attribute. The ID attribute provides an ID. It's an ID, excuse me a second. It's an ID that identifies an object, gives an object a unique identifier within that document so other things can reference it. The ref attribute provides a reference to an existing ID. So an object can have a ref attribute with an ID string in it, and that will point to an ID somewhere else in the document. Then finally, we have a metadata attribute, which is used for objects to say which metadata applies to them. We'll learn more about metadata about 3 topics from now. So we're just going to hold off on that for the most part until we get to that topic. Now these leverage built-in XML schema attributes. XML schema already provides this referencing. We are not doing anything special. We're doing plain old XML schema. But we're renaming things a little bit. XML schema uses a capital ID to assign an ID to something. It uses capital ID ref to provide a reference to an ID elsewhere. And it uses capital ID ref to provide a reference to multiple IDs in one attribute. And because these are all uppercase and they're fairly long and they're not really self-explanatory, we rename them. And really all we're doing is renaming them. We're just renaming ID, ID ref, and ID refs, plural, as ID, ref, and metadata. It's the same thing, plain old XML schema stuff. Now, you may have done a lot of XML and never known that XML could do referencing like this. Well, it can. A lot of people don't know it can. This is plain old XML schema. This is nothing NIEM specific, but we do rename them to make them a little easier to use. So again, the ID. It assigns an ID to an object. It's just a string. That's all it is. It's a string. It's an ID string. It has to be unique within the instance document. Not unique in the real world. This isn't a real world ID. This isn't like a social security number or a database ID. It's just an ID that's unique within an instance document, within the XML document, so that another object can point to it and know which object it's pointing to. So it has to be unique in the document, but it's not a real world ID. This is an infrastructure ID. This is an ID for inside the document, and it doesn't have a real world analog. It can't include a space. The reason why is down below when we talk about the metadata one, that represents that points to multiple IDs and they're space delimited. So you can't have a space because they're space delimited. The ref attribute is a reference to an existing ID on another object. It contains an ID string. It's a single ID string, just like the ID attribute does. But instead of assigning that ID to the object, it's defining a reference to another object that has that ID. And that ID must exist in the instance document. So if object number 2 points to an ID and there's no object number 1 with the ID, an XML validator will raise an error because the ID has to exist. But validators don't check that the ID linking makes any sense. If I'm saying, hey, this object here is a person, it's a reference to a person and the ID is on a car, validator doesn't care. A validator only cares that if I've got a ref to an ID string, an ID with that same string has to be somewhere in the document to point to it. Then the metadata one, the final one here, references IDs of metadata objects. We haven't talked about metadata. We will. Again, it's just 3 concepts down the line. But what it's saying is the object is saying, here are the pieces of metadata that apply to me. and it's going to do that with an attribute. The attribute is called metadata, and it will contain multiple IDs. It can contain one, but it can also contain multiple IDs. They're space delimited, and they all must exist. So if I have a metadata attribute and it has 3 IDs in it, all 3 of those IDs have to exist in the instance document, or a validator will throw an error about it. So examples of how NIEM uses these are in the next few sections, but here's a non-NIEM example just so you can see how they work before we add NIEM complexity on them. So in the top example, plain old XML using the XML attributes as is in XML schema. We have a cat. There is no cat element in NIEM. Okay, there is some animal stuff, but there's no cat element. There's no specific cat element in NIEM. But for our little example here, we got a cat. The cat has a name. Cat's name is Jet. The cat has an owner. Who is the owner? Well, this is an ID ref. It provides a reference to an ID somewhere else, marking an object with that ID. The ID is owner 01. So who is the cat's owner? Well, you got to go look. You got to go look for something with an ID of owner 01. Here's a human. Human's got an ID of owner 01. Ah! This human is named Tom. So the owner of this cat named Jet is this human here named Tom. That's what it's saying. That's all it's saying. You give an ID to the human, and the cat owner element has a reference to that owner. You notice this little slash bracket here. It's a little different than the XML we've seen. Usually we see an opening tag and the value in an ending tag. If there's no value in between the tags, you can do what's called a shortcut. You can just shortcut the XML. Instead of a caret slash in the element name and another caret, you just do a slash, not caret, but angle bracket. You just do a slash angle bracket. It's the same thing. It's just like open cat owner, close cat owner. You'll see this a lot when there's no data for it, rather there's an attribute inside, which is exactly the case here. We're not putting info about the cat owner here. We're using this to point at it. The info about the cat owner is this human down here. Plain old XML. NIEM works exactly the same way. We just rename the attributes to make them a little easier to follow. So in this case, the human has a lowercase ID of owner 01, and the cat owner element is reference to that owner 01. It's just ID and ref. It's just clearer, easier to deal with, easier to read, easier to type. Note again that this ID is just unique to this little document. This isn't a real world thing. This isn't this Tom, which is me. It isn't my social security number. It isn't my driver's license number. It isn't my employee ID. It isn't anything like that. It's just an ID internal to this little chunk of XML so that we can link this cat owner to the person who is the owner of the cat. JSON LD also provides this sort of referencing. It's a little bit different, but it works essentially the same way. Now, JSON itself doesn't have a means for linking objects. It's not really a JSON thing, but JSON LD does. The LD, after all, stands for linked data, and JSON LD is all about being able to link things together. So it handles it, and it handles it with a single attribute called @ID. And there's just one. It doesn't have separate ID and refs. It just has the @ID. So what happens here is the JSON has an ID, value of owner 01. Again, there's a hash mark on the front. I'm not enough of an expert in JSON LD to explain why that has to be there. And then the human has an ID, owner 01. Same ID, links these two objects together. Now you can look at it from either direction. You can say this cat has an owner, and that owner is Tom, or you can say Tom is the cat's owner. But it's basically it's the same linking, just doesn't have the explicit ID and reference that it does in XML. It just has two IDs for the two things that are the same. Make the IDs the same, that provides the link between them. So what does NIEM do with this information? What does NIEM do with this technique? Well, the first thing NIEM does is it does associations. So we talked earlier when we looked at this UML, we looked at the person, we looked at the charge, and we noticed there was an arrow, a double-ended arrow connecting them. That double-ended arrow is just a relationship between these two objects. And while we're at it, well, let's actually go and map charge, and let's map a description for it, and let's go see if we can somehow have a Boolean about whether this charge is a felony or not. Let's go do all that. Let's go do the mapping. So relationships are complex, and that's why we want to have these associations. You know, you can't just say the person has a charge. People don't have charges as part of themselves. Having a charge, a legal charge against me, is not part of my identity. Nor can charges really have people. They're separate objects. Let's treat them that way and relate them together, because that's how the real world works. NIEM provides an association object for doing that. Actually several. A whole family of association objects for linking people to activities and people to locations and organizations to activities and all sorts of permutations of it. There is a trade-off here in implementation complexity. It can be more complex to follow these IDs and ID refs than just grouping things under each other. So there's a little more implementation complexity. Associations link objects together. The associations reference the associated objects. Thus, they can link to multiple objects, and you can form many-to-many relationships. So we could have an association with multiple people and multiple charges and have them all related together. Associations also hold information about the association itself. A date would be a common one. Here's the date of the association, or a start and end date for the association. And if you want, though, associations can also just include the item, if that's what makes sense for you and you don't want to do the referencing. NIEM rarely makes you do the referencing. You can also just include objects if that's what works best. We're going to see examples of both as we get into the example. So we want to relate a person and a charge. How would we find that? Well, luckily, there's a person-charge association. Let's go take a look, though. Let's go look at the SSGT. We're going to go and we'll just search for the two things we want to relate. We want a person, we want a charge. And go search. And we'll get back some hits. And we'll see there's a charge. There is a person charge that can go inside of things, or that is of charge type. So that's one possibility if we're working in a context where this is what we want. But we also have a person charge association, which, hey, that might be really good for linking a person and a charge, just like we're doing. Well, let's open it up and see what it's got. Person charge association. It contains a charge. Yes, that's what we want. And it contains a person. Yes, again, that's what we want. We want to associate them together. Now, I noted how associations will also have other information about the association itself. And you see one of those here. Juvenile as adult indicator. This is if the juvenile is to be processed as an adult, false otherwise. This is in the context of the association between this person and a charge. It's not applied to the person. It's not about whether the person is a juvenile, and it's not about whether the person is an adult. It's about, in the context of this association, is that juvenile being charged as an adult. It's specific to the association. So, we've got a charge, we've got a person. If we look and show inheritance, we're going to see a little bit more. We can open an association type, what it's based on. And there we have a date range, which we can open. And it'll have an end date and a start date. So if we wanted to get the date of this association between the person and the charge, we could do that here. Now, we don't have that in our UML. That wasn't part of our business requirements. But if we wanted something like that, we'd be able to do it. So that's what it looks like in the SSGT. SSGT, because associations are so common in NIEM, you can actually filter by associations and just search for person charge within an association. And there you get fewer choices because it's filtering out all the other stuff. So it'll do that kind of filtering. You can look at it in Wayfair just as easily. Well, not quite, because Wayfair doesn't do the association specific search. But if you want to add that, you can just add it as a search term. And there we get person charge association. Same thing. So easy to find. See, like I said, a lot of the searching is easier than you might think, and it's true. It is a lot easier than you might think. So here's the schema. Here's how it looks in schema. We got a person charge association. It's a person charge association type. Provides an association between a person and a charge issued to that person. That's exactly what we want. We want this relationship between a person and a charge. If I go look at person charge association type, you see it contains a person and it contains a charge. So if we want to, we could just have a person charge association object, stick a person inside, stick a charge inside. But we're not limited to just that. Suppose we want to have we want this person used in more than one place. then do we replicate the person? Suppose we need the charge referenced in more than one place. So we have the ability to have the person and the charge external to the association and just have the association linked to them. Let's go a little further and see the association type, which we just did in the SSGT. Here's the association type it's based on. There's a date range. Oh, and then there's a description. There's a description for the association itself, and that would get inherited. So put it all together, and you get an instance document that starts to look like this. So let's look at it first, and let's talk about some implications. So this is one way to do it. Person-charge association contains a person with a reference, P01. Contains a charge. It's a reference to CH01. These both have the shortcut here. They don't have actual person and charge information inside the association. Rather, the person's out here on its own with the ID, P01. So, who is the person that's being associated with a charge? It's Peter. We know because he has the ID P01, and that's referenced by the person object. And the charge is down here. How do we know this is the charge being associated? It's got the CH01, which matches this here. So all of this says Peter is associated with this particular charge. Now, we should go look. We're going to map some things about charge too. Let's go look. We need a description. We need felony. You can see the answer there, but it's good to go and look. So let's look at our charge association. Here's the charge. What does that have inside of it? Does it have a description? It does have a description. Awesome. So there we are for that. Does it have any felony stuff? Down here. Now, one thing I also like about Wayfair that doesn't work quite as well in the SSGT is because Wayfair lists everything, you can just Control F your way through things too. So if I was looking for felony and I didn't want to scroll my way down, I can just start to search for felon, and that gets me to it rather quickly. There's a couple of matches, because then you get down here for the list of all the things. But so you can find things easily by Control F-ing your way through a Wayfair page. You can still do that in the SSGT, but you need to have expanded the right things first. So it works a little better in Wayfair. Again, these tools each have their pros and cons. That's why I use both extensively. I think you should too. Now, why would we want to do this? Why would we want to have these as separate objects? Well, there's a couple of reasons why. Because this kind of referencing brings two advantages. Advantage one is no duplication of data. So if I just have one person object, it's just representing a person, representing Peter. If Peter is in there just once, and everywhere that he as a person is used is referenced to his one instantiation in the XML, then I'm not duplicating data. Now, is that a problem? Well, it depends. If it's just Peter's name and his birth date, then no, it's probably not a big deal if you've got 3 Peter objects in your XML. But you can do things in NIEM like, include a mugshot. You can take binary images, take an image, you can convert it to a text format, typically base64, but there's multiple different ways you can do it. But base64 is one. Base64 converts binary images to pairs of characters. And so you can embed binary data into your XML. And I've seen this done in the real world on real exchanges that I've worked on. The bad side when you do that is it becomes very big. A binary file becomes much larger when you convert it into text like that. So now suddenly you have an exchange with Peter's mugshot, and it's a lot bigger. And if you had that mugshot in there 3 times, now it's 3 times a lot bigger. And that can actually impact how a system works. And that can impact your bandwidth if you're doing it all the time. So sometimes you really don't want to duplicate data simply because it's a lot of data. And the more times you have it in there, well, it just causes you more stress on your system. The other part is knowing that an object is the same object in reality and not just 2 objects with the same name or the same identifying information. And let me give you an example, and the example is me. Okay, so my name is Tom Carlson, which you saw at the very beginning of the training, so it's not a secret. And I grew up in Minnesota, but right now I live in Virginia. Now, if somebody tells you there are two cats. So Jet, who is my cat, but we have a second cat named Knuckles. If somebody tells you these two cats both have an owner named Tom Carlson, and you're in Virginia, chances are it's the same guy. Carlson is not a common name in Virginia. Virginians have trouble saying it sometimes. The further south you go, the harder time people have. The L in the middle throws them. They want to say Carson, and they try to throw an L in the middle. It becomes Carlson instead of Carlson. It's an odd name for some areas of the country. So, two cats, owners both Tom Carlson? Yeah, probably the same guy. But if you're in Minnesota, well, then things change. Things change drastically. The phone book has pages of Tom Carlsons. No exaggeration, pages of Tom Carlsons. I spent 8 long years at the University of Minnesota. At no time were there fewer than 4 Tom Carlsons enrolled at the university. I lived next to campus for a year in an apartment, and I couldn't write checks in that neighborhood because one of the other Tom Carlsons was writing bad checks. So Tom Carlson was not allowed to write a check. My Little League baseball team had a second Tom Carlson on it. We had to write our names on our baseball gloves. He was better than me, so I had to label my glove as Tom Carlson number 2. That's how common Tom Carlson is, a name in Minnesota. So if you have 2 cats and they both have an owner named Tom Carlson, you probably should not assume that that is the same person. And having referencing like this is a way to make sure it's the same person. If I have a Tom Carlson object and 2 cat objects and they both reference the same Tom Carlson object, that's pretty good verification that that is the same Tom Carlson. If I have 2 cats and 2 person objects and both cats each has a Tom Carlson as their owner, or if it's just the cat has Tom Carlson as the owner name inside of it, there's no guarantee in Minnesota that that's the same Tom Carlson. It's an unsafe assumption. So referencing allows you to say that this is the exact same object, not 2 objects that just happen to look a lot alike. But if you're okay with replication or duplication of data, and if you're okay with having something in an exchange multiple times, then you can just put it inside, which is the second example. So again, first example, we got referencing. We got references, they go to the IDs, the person object is outside of the association, the charge is outside of the association. But if you want, you can just tuck them inside. Here's a person charge, person inside, charge inside. This is easier. This is easier to implement and frankly easier to eyeball and understand. So if you're okay with that, then you can do it that way. NIEM doesn't make you do the referencing. You do the referencing if that meets your needs. If it doesn't meet your needs, you don't do it. You can also mix and match. So in this case, for example, probably the smartest thing to do is have the person outside, because Peter's going to be referred to more than just here, but then have the charge inside because nothing else is going to refer to the charge. And you can do that. You can have the person outside with a reference and the charge actually inside the association. NIEM never requires you to do this referencing. Okay? You don't have to do the referencing if you don't want, but it's there for you to use, especially in the case of associations. It's there for you to use. JSON-LD works the same way. It just mirrors the XML document. So you got a person charge association. It's got a person inside of it, but all that person has is an ID of P01. Has a charge, but all that charge has is an ID of CH01. And then outside of the association, separate person object with that ID, and then his name, Peter, and the charge with the ID for the charge. Description text, we found that in the SSGT, and the felony indicator we found in both the SSGT and Wayfair. So we just add those in. It looks just like the XML version. As with XML, you can just include them inside. So if you want to do it this way, charge, person inside, charge inside. Association containing the person charge, that's fine. If you're a JSON developer, this is probably a lot better. You probably like this a lot better than the referencing anyway, because referencing just isn't really a JSON thing. So let's go take a look at our attributes that we get from that. Okay, so we did the association, And this is all the stuff we added. We added the person in charge association with a person in charge inside. Now we're going to use this as a reference, and this is a reference, but right now I'm just getting the structure of how these things fit together. And then we added a charge to it with the description text we found and the felony indicator that we found. Cool, making progress. Mapping spreadsheet. Well, we got some new blue lines. We had to add a bunch of stuff though, because we decided to do this with referencing. Again, you don't have to, but we are for the purposes of the training class. So the association itself, now there isn't a line here for the arrow, but it is actually on the UML diagram. This is mapped to the arrow itself, is the person charge association. Inside of there is a person and a charge, and then outside of there we're making a charge with the description and the felony indicator. We grab the types right out of NIEM. The contained in, the person and that first charge are both going inside the association. Again, they're just going to be used as references. The second charge, the charge that lives outside, we're not sure where that's going to go. We're also not sure where the association is going to go. They're just right now just kind of sitting all at a peer level with person and with crash. Description, text, and felony indicator both go inside that charge. Here, we're finally going to use the category column because we're going to say, hey, this person element here, this is a reference to one somewhere else. We're not going to have a whole element here. And this charge is a reference to something else. We're not going to have the whole charge element here, but this is the actual charge element. This is where we're actually going to put the charge stuff. So it's important to have the category there to give you that clue. It's important to me anyway. Again, your mapping spreadsheet doesn't have to have this. We have our cardinality, and we have our exchange path. Association with the person and the charge inside, and then outside of the association, those are both going to be references, and outside we have our charge with the description text and the felony indicator. So that gets us back to our notes. We're making a lot of progress. Let's look at our UML so far now. Now we're getting to something called roles, but you notice, hey, we've been crossing things out as we go. We got the charge. I don't have a way to cross out the connection arrow here. I don't have a way to cross that out to show that it's done. But we've done the charge and the description, the felony. We have a little more to do on the charge, but that's a later topic, just like we have a little more to do on the crash. Now let's look at the injured person and their description. And this requires a little explanation. It's very tempting to model things as specializations all the time. And indeed, that's what this UML does. This UML says, hey, the injured person is a special kind of person. And the driver is a special kind of person. And that all makes sense until you try to actually represent it. Because now you're stuck with a problem. I've got this guy, I've got Peter driving the car. Peter crashed the car and Peter got hurt. How do I represent that? If I make special kinds of things, do I make a special driver person and then a special injured driver person from that? Or do I make a person, I have a person and then I make a special injured person, and then from injured person I make a special injured person who was driving? Injured driver? It gets weird. It gets strange. It gets overly complex in terms of trying to make this work by specialization. And when you take a step back and you look at it, you realize, these aren't special kinds of people. The driver of a car is not a special kind of person. It's a person playing a role of being the driver. Same with the injured person. The injured person really isn't a special kind of person. It's just the person playing the role of being injured. Now, playing the role is terminology that minimizes. It feels like it minimizes, and it's not meant to. It's not meant to say, oh, you're injured, you're just playing a role. But it is a role that you are inhabiting for a limited period of time. Certainly you weren't injured before the crash. You weren't injured before the crash, so you weren't an injured person then. It at least has a start date and hopefully an end date where you're fully healed. So it's a role that a person plays. Being the driver of the car is a role a person plays. And it becomes easier to model these things when you think of them in terms of roles. And that's what NIEM does. Roles are roles that people play. They can be played by people in NIEM. They can be played by organizations. And they can be played by items. there's one domain that has some other roles in it too, which is kind of esoteric. I don't fully understand what that domain is doing. The rest of NIEM, people, organizations, and items can play roles. Roles reference the object playing the role. So the role points to the object playing it. The driver is going to point to the person playing the person object playing the role. The injured person is going to point to the person object playing the role. Objects can play multiple roles then because multiple roles can point to them. A single person, Peter, can have the driver point to him and can have the injured person point to him, and that works just fine. Roles also can include the object playing the role. We just saw associations, right? We saw where you can have that person-charge association point to the person or include the person. If we want, we can include the person inside a role. So we can have a driver role with a person inside of it, and if that were the only role the person was playing, that's probably fine. But it's not a special kind of person. It's a person in the role of a driver, just included inside for convenience. Roles also contain information about the role itself. So, start and end date for the role, things like that. An injury description for that injured person. And we're going to see all these examples as we go. So our example is going to be crash person. And what you'll see, anything in NIEM that contains a role of person, a role of organization, or a role of item element, that's a role. There's a few other ones, but we're not going to get into those. These are the three major ones, the ones you're going to run into. Those are roles. If it has a role of whatever inside, then it's a role, and another object can play that role. These can all be pointers, or they can be the actual thing. But before we go and actually search for them, let's talk about trying to find the injured person, because it's not that trivial. Okay, so first thing, we'll search for injured person. Let's kick off an SSGT search. Let's kick off a Wayfarer search. Wayfarer doesn't find injured person. That's apparently not the terminology. We do have an injury location code. That's a hint. Maybe we could use that. Let's not go there quite yet, though. Here's SSGT. Again, there's no injured person there. There's no injured person. Well, let's go back to our notes. No results. Well, how about person injury? Or even better, if we were really smart, we'd drop the Y. We wouldn't do the Y. Note, injured, past tense, ed. Injury is a noun. It just ends in a Y. If we just do INJUR, we're going to catch them both. So when I talked earlier about dropping the endings from words and just using kind of the root of the word, this is an example of that. Let's do person injury or just person injure and probably get better results. So let's go ahead and try it. Do it in the SSGT, and we get an injury. Oh, crash person injury. That sounds really good, doesn't it? That sounds like just what we need. Let's kick it off in Wayfarer as well. See what Wayfarer gives us. Crash person injury. Cool. If we look at crash person injury, then we'll learn some things about it. Because this is an injury. This isn't the person yet. This is the injury. But it sure looked good, right? It sure looked good. And we'll notice some things. For example, we might notice that a injury location code is something a person would have. Or we might be looking at the injury. So let's look. There's a couple of ways to get to this. So one is here. We searched for injured person, and we saw injury location code. And we want, an injured person probably has an injury location code, right? Start at the bottom and work your way up. Okay, let's start at the bottom and work our way up. Here's an injury. What does an injury location code go inside of? It goes inside anything of injury type. For example, a crash person injury. That's convenient. This is an example element of this type, and it's just alphabetical. The first one that is of this type, and crash person starting with a C is the first one. But it's handy for us. Crash person injury, awesome. Here's a crash person injury, and that's where we are in this other tab too, right? Crash person injury. So let me go back to the original tab. And what does that go inside of? Oh, that goes inside of things of crash person type, like, hey, a crash person, awesome. So that's our injured person, a crash person. And then if we look and we go, oh, hey, that's inside of a crash. Oh, now we even know where it sits in the wider world here. We know that we have a J crash already because we did crash date, and we know crash person goes inside. Huh, cool. We figured it out from the bottom up, from finding an injury code to working our way up. But we could also have gone the other direction. We could have said, well, what kind of thing would contain the person injured in a crash? Well, then maybe we just say, well, let's start at crash. Let's do that in the SSGT because the SSGT excels at that. But we could do the same thing that we did just in Wayfair. Injury location code? Cool, we can look at that. What does it go in? Well, it's substitutable for injury location abstract. Let's go to that. So we're going up one level. And what does that go in? Well, that's contained of anything of injury type. So I click on injury type. And then we can find the elements of injury type. And we find, down here, crash person injury. And that gets us to the same spot we were in Wayfair. It's a slower process. Going up the chain from very specific things to more general things, easier to do in Wayfair. But exploring from the top down, easier to do in the SSGT. So let's go and actually start at crash for this. So we did bottom up. We just did bottom up. We found something really particular that an injured person would have and worked our way up. But we could have gone top down. Could have went, well, this is probably inside a crash somewhere. Let's open up crash. And then we would look and we go, oh, there's a crash person. So we could go that way as well. And then if we open that, we see the crash injury that we just talked about. Go down, and there's crash person injury, go down from there. So not trivial to find out that the injured person is a crash person. But we have a couple different ways to get to that. Top down, bottom up, they both worked and they're both good ways to do it. So that's why they're both listed in how to do searching. Listed them both there because you'll use both of them. Let's go back to the notes. And we figured it out inside a crash person. And then by looking at crash person, we saw that one inside of a crash. Cool. Now, the way I like to think of roles is I like to think of roles as baseball caps, because a lot of the things about roles fit really nice into these as basically a metaphor for a role. So the nice thing about baseball caps is you can have multiple baseball caps. So here's one, here's two, here's three. Think of each of these as playing a role. Say, for example, I'm a person and I'm a police officer. Blue hat, police officer role. And I was assaulted. As a police officer, somebody assaulted me. I'm a victim. That's the red hat, I guess, because I bled some. So red hat, that's the victim role. Then we got the green hat. This is me as a witness to the assault. Right? So these are three different roles I play. Now, we don't want to make a special police officer victim witness person. We don't want to do that. That doesn't make a lot of sense. We do want to have three separate roles for it. And what I like about these roles is that I can play these roles in different combinations, right? I'm police officer Tom, walking along, and then, well, I get assaulted, and now I can wear two hats. And then later, when it goes to trial, maybe now I've got three hats. Now I'm the witness. And then after that, those come off, and I still continue to play the role of police officer, and eventually I retire. And then I'm not playing a role at all. So it's really handy. Now, the other thing about these that make them really, really handy as a metaphor for roles is that we know that roles point to the object playing the role. That's the bill of the cap. So, ta-da! This is a police officer role pointing to me playing the role of a police officer. But we also know that if we want to, we don't have to do that referencing. We can just put the person right inside the role and actually stick them inside the hat. The other nice thing about these is that you can put things inside of hats. So we talked about how roles can hold information specific to the role. Well, we're just going to pretend this is my police officer badge. Goes right in the role. And the hat can hold information about the role and still kind of put it on. It is less comfy that way. But that's how roles work. Roles are like baseball caps. And whenever I have to think about roles, I think of them as baseball caps. In the schemas, it looks like this. So here's our crash person. And it's of crash person type. If we go look at crash person type, so here's crash person type, starts from object type. It's a little different from associations. Associations have a dedicated association type that they are based on that provides basic association things like starting and end dates. Roles instead don't. There is no role type. Roles are just, you want to make a role, you put a role of something inside, and you got yourself a role. So indeed, that's what crash person does. There's the role of person. It can either hold the person information and actually be a person, or it can be a pointer to a person somewhere else. And then there's things about being a crash person, like the injury. There's also things like EMS transportation, but injury is what we're focused on because that was part of our UML. So we have a crash person. So if crash person type starts as an empty container, adds some things about the role, and then adds a role of person to provide the pointer to the person. And then finally you have the role of person object, which is of person type. It's actually a person. It can be a person or it can be a pointer. It has a substitution group role of abstract, and that is for cases where something can be a person or an organization or an item, and instead of putting it in 3 times, we just put a role of abstract in there once, and then it gets substituted by any of them. So that's just a convenience. What does it look like? Well, and it's going to look like this. So this is very similar to what we saw with associations, right? We have a crash person role, so very similar to associations. Crash person role, element here. Inside of it is a role of person with a pointer to P01. So who is playing the role of crash driver? That would be this person here with the ID P01. That's Peter. Peter is playing the role of the crash driver. Again, though, if you do not want to do the referencing, that's okay. You don't have to. Crash driver, that's the role. Who is playing the role? The role of person, this time acting as a person object with the name Peter. Identical. They're equivalent things. They mean the exact same thing, only this puts the person inside the crash driver. Again, why would you not want to do this? Why would you want to do the referencing? Well, because we're using Peter somewhere else. We're using him in that person charge association as well. So instead of having 2 person objects, both of them being Peter, we're having only 1 person object representing Peter, and we're having other things point to it. So we're having the person charge association point to the single Peter object. And we have this crash driver role of person pointing to that single person object representing Peter. They both point to the same object. We know it's the same object. We know it's not just 2 guys named Peter Whimsy. We know it's the same guy, and we're not replicating the information about Peter multiple times in our document. So that's why to do the referencing. But again, you don't have to if that's not what works for you. JSON LD looks the same. Crash person, a role of inside, it gets an ID, matches the ID for this person here, same ID, that's Peter. Again, lacks the directionality that XML schema has, so it's just kind of this role of person and this person have the same ID, so they're the same thing, but that's fine. Again, as with associations in JSON, you can put them inside, so crash person, role of person, who is playing the role? Peter. We're going to put him right inside. We're going to make this role of person be Peter. Again, which way you go depends on your balance. Easier to do it with inclusion, but not as powerful. It just depends on what your needs are and what you're comfortable with in terms of implementation. So let's look artifacts for it. Here we've added some stuff for the role. We've added the crash person role. We've added the role of person to point to the person playing the role. And then we have the injury with its description. We found that in there as well. So we picked up all those things. And then look at the mapping spreadsheet. And here is the mapping spreadsheet. So go over to the left and see we're dealing with the injured person. But it's not a special kind of person, it's a role, and that means adding some more extra lines. That's just the nature of it as we go to something more complex. So we got a crash person that holds a role of person. The role of person points to the person playing the role. And then the crash person role itself has an injury, and that injury has an injury description text. We just keep building it out. Copy the types from NIEM. The contained in. So this is the injured, the crash person, and they're inside of a crash. And again, we found that in 1 of 2 ways, right? We started from the bottom up with the injury. It worked our way up to the crash person injury, to the crash person, and up to the crash. Or we could do it the other way. We look at a crash and understand the crash object better and see that it has a crash person inside and find it that way. Either way worked for us. SSGT, better for that kind of top-down. Wayfarer, better for that kind of bottom up. You use the tool that's best for whatever your needs are. The role of person goes inside the crash person. The injury goes inside the crash person. And then the description of the injury goes inside the crash person injury. Under category, I make a note that this role of person is going to be a reference to the person. It's not going to be a person object itself. Definition straight out of NIEM. And then here's our exchange path for it here. Got a crash object. We're not sure what crash is going into yet. Remember, we created it when we did the crash date. It's still hanging out there, but now it's got a crash person inside, and that's got a role of person inside, and that has crash person has a crash person injury, and the crash person injury has an injury description text. As we just work our way down, we're continuing to build the structure. Again, this matches the structure that we saw in the text document we just looked at as well. Building the structure and documenting it here.